Hello, welcome back to the lesson video from Make a Wit. And this is the last video for the first semester. Again, with me, teacher Sunni, and together with secondary 1. The topic is about scientific notation on lesson 8 here. Last lesson, everybody. Are you excited? Yes, I am. Now, today we will be talking about powers again, but it will be 10th power. Now, let's see. Review from last clip. Exponents is in the form of the base number and exponent number or power. Alright, and how can you call it? It's called a to the power of n. Alright, a is any whole number, and that means a times itself n times. Yes, a to the power of n means a times itself n times. Now let's see. If you have number 32 over here, how can you put it in exponential form or put it in this form, the base number and the power or exponent, right? So you need to do it by find all the factors of this number 32, but it needs to be prime factors. Okay, so let's see. This one comes from 16 times 2, right? Equal 32 here. And see, which one is the prime number? Yes, number 2. So you stop for now. But if it's not prime number, you need to do more. You put it into small numbers, okay? So which number can times together equal 16? Yes, 8 and 2. Now, again, when you hit prime number, you stop, but then you continue on the normal number over here. So 8 comes from 4 times 2. Again, you stop with 2 and then continue on number 4. And then you will get what? Number 2, right? Or 2. So how many? 1, 2, 3, 4, and 5. So there are 5 2's. So 32 equals 2 times itself 5 times, right? Now, it will be 2 to the power of 5. 2 will be the base number, and number 5 will be the power. Okay, now let's move on. Laws of exponents. Last clip, we also learned about laws of exponents so that we can operate them, right? So let's see. First one, 0 power, remember, equal 1. 0 power equal 1. Now, a to the power of 0 equals 1. Very good. Next, 1 power is actually the same. It remains the same, just like you look into the mirror here. Okay, so a to the power of 1 equals base number. Very good. Equals a. Now, next, products of powers. So products mean times. Very good. So let's see. It's actually plus. You use plus with the power. See, a to the power of m times a to the power of n equals a to the power of m plus n. Okay, you plus all the powers together. Plus it all. This is the product of power. Next, quotient of powers. So it will be minus. Okay, let's see here. So you minus the power together. See, a to the power of m over a to the power of n. That means same base, use division, right? So you will minus. But which one will be the first number? M or n? Very good. The top part, so it will be m. A to the power of m minus n. Okay, last one. Negative power is called inverse. So that means it pull you down, right? So a to the power of negative n, you pull it down, it equals 1 over a to the power of n. Okay, move it down under number 1 here. Okay, now let's move on to our lesson today. Now, our lesson today will be about scientific notation. It is a quick way to write a really big numbers, like the diameter of Earth. See, from here to here, Earth is very big, right? So if you write it down, it will be very hard to look, very hard to read. So the scientists found a way to change it into the notation so it will be easy to track down the number. And again, if you can read big numbers, you can also read or write a really small number, just like size of viruses. You see, coronavirus is very small, right? Super small particle. So you use a lot of zero. It's just like 0.000 too long. So it will be easier if you use scientific notation. Okay, now let's see how can you do it. Scientific notation will use powers of 10. They can create short versions of long numbers. Now long numbers can be big numbers or small number. This one, do you think big or small? Small, right? Half point and a lot of zeros. So this is long numbers, but it's actually very small. Again, this one is very big, right? 2,000 billion, so big. And again, super small, but it's really long, and you can read it, but it will be hard to read because a lot of zeros. It can make some mistakes if you write it like this. So scientific notation is a good way to do it. All right, this is example of the long numbers, super long. Now let's see. You use power of 10. Power of 10, so that means the base number will be 10, number 10 only, and the exponent can be a lot of numbers. So let's learn how to do scientific notation. First, the form will be a times 10 to the power of m. Now scientific notation is written in two parts. Do you see? A is part 1, part 2 will be the power of 10. Now part 1, a is a number between 1 and 10. It will be decimal. Okay, decimal. 1 and 10. It cannot be less than 1 and it cannot be 10. And see, a cannot be less than 1 because it can be 1, but it cannot be less than 1. But for number 10, a cannot be number 10. A needs to be less than 10. Part 2, multiplied by a power of 10. Here, power of 10. So 10 will be the base number for the exponent form. All right, now let's see. What is a decimal? Do you remember? Decimal is a number that has decimal point, or a decimal number contains a decimal point, like so. Here, point. See, decimal point is called decimal. Now, how can you read this one? 1.1. Okay, 1.1. And what about this? How can you read this one? 2 point, not 28, but 2.28. And next, 20, yes, just like normal. Before the point, you just read normal, but after the point, you read one by one number. So 20.20 or 20.2, same. All right, if you have 0 before, not before, after the number, you can just cut it out. You can just cut this 0 out. It remains the same for the value. Okay, but if 0 is before number 2 but after the decimal, then you cannot cut it. Okay, now let's see. Part 1, you need to find the decimal. Okay, rule number 1. See, the form will be part 1 and part 2. This is rule number 1 for A. Let's find out. Is a decimal between 1 and 10. Let's see, which decimals cannot be in scientific notation? Between 1 and 10? Is it between 1 and 10? Yes. Yes or no? Yes. How about this one? Yes, of course. What about this? 1.042? Yes, it can be in the scientific notation. What about this one? 9.3? Yes, of course. What about 0.7? No. It cannot be in this form because it's less than 1, right? Less than 1. What about this one? 1.24? Yes, 1.24 is yes. What about 10? No, cannot be. It can be less than 10. 9.9 maybe, but 10 no. 8.2? Yes. 0.1? No. 2.2? Yes. 29.05? No, no way. It's more than 10. How about this one? 0.12? No, it's less than 1. 7.7? Yes. 0.3, last one. What about this? No. Alright, so now you have it. You need to remember A can be between 1 and 10. It can be 1, but it cannot be 10. And then the number in between. Okay? Don't forget. A is greater than or equals to 1, but less than 10. Okay? Rule number 2, it will be about, guess what? This. Power of 10. So, multiplied by an exponent with base 10. See? 10 to the power of 8, right? So this one is not 10 times 8. Don't forget, it means the base number times itself according to the power, right? So 10 times itself, 10 times. Oh, 8 times, sorry. 8 times over here. And then you can just count the zeros, right? 1, 2, 3, 4, 5, 6, 7, and 8. See? 8 zeros. Now, next, what about this? Oh, you count the places after the first digit, okay? If it's positive power on the base 10, you count it after the first digit. This is the first digit, okay? The number that on your left. Alright, but what about this one? The negative power on negative exponent. Same, base number is number 10, 10 to the power of negative 8. So now it's just like this, 1 divided by 10. How many times? 8 times, see? So it's just like 10 times together, 8 times. But of this, divide number 1 over here. So it will be 0.1, 2, 3, 4, 5, 6, 7, and 8. Okay, so this time you will count the places after the decimal point. Okay, the decimal point is here. So if it's negative exponent, you will count after the point. But if it's positive, you will count after the first digit. Don't forget this. Very important. Alright? Scientific notation is not that hard, everyone, but you need to count and be careful when you do it too. Now, with the positive exponent, let's see. Now, as we multiply, the number gets bigger. For positive exponent, the number will be really big, okay, or bigger. Now, see, 8.1, yes, according to the rule number 1, is less than 10, right? But more than or equals to 1. Now 8.1 times 10 to the power of 1. So it's just like that. After the first digit, you count only one place, right? And what about this? You start counting after the first digit for the positive exponent. And what about to the power of 2? Same base and then same digit, same decimal. It will be 0 after. See? 8.1. So 8 and 1 same. But then if you don't have another number, you put 0 after. Okay? After the first digit, it will be how many places? 1 and 2. That's it. What about this one? You put 8 and 1. Right? And then you put 2 more zeros. Because you count the places after the first digit will be 1, 2, and 3 over here. And what about this one? Same. You can count, see, 1, 2, 3, and 4. Alright? So, kick the decimal point to the right. See, this is decimal point. You kick it to the right here. You kick it. You kick it. Yes. And then, see, you kick it according to the power on the base 10. Here, you kick it 1, it will turn out to be 81. You kick it to 2 places. 1, 2. When you kick it, if you don't have the number to kick, you put 0. Same. 1, 2, 3. And then, to power 4, 10 to the power of 4, you kick 4 places, right? But then, if you don't have the digit, you just put 0 after that. Easy, huh? So, as you can see, if the power got bigger, then the number will be bigger too. Alright, now let's move on to the negative exponent. Now, as we multiply, the numbers get smaller. Okay, will be really small or smaller. Let's see, same digit, same decimal, 8.1. But then, what happened? You will start counting from the old decimal point here. From here, 8.1, right? You count to the left. Okay, you count to the left like this. 1 places. See, let's compare the old one and then move to the left. You kick it to the left for negative exponent. What about negative 2? Negative 2. You kick more. See? 2 places. And what about next one? You kick it even more. 3 places because it's negative 3. Here. 1, 2, 3. See? If you don't have the digit, you just put 0. This is 8.1, right? You don't have digit before number 8, so just put 0. Next. 4 places. Okay, just kick the decimal point left for the negative exponent. And according to the power, if the negative getting smaller, this one, negative 1, is bigger than negative 4, right? So negative 4 is the smallest here. So it will be smallest, number 2. Yeah, it can be even smaller if you use 10 to the power of negative 5, negative 6, on and on. Okay? Now, let's see. Let's try. It's your turn. But don't worry, I will help. See, what is the standard form of this scientific notation? Now, let's start from the captain over here. This is called scientific notation. It has 2 numbers apart, right? First one will be the decimal, and part 2 will be the exponent base 10. Alright, let's see. Standard form, you can just convert or change it into normal number. How? This is how many places that you need to move the decimal point? 3. Then 3 is positive or negative? Positive, right. So you kick it to the right. Okay, positive, go to the right. Alright, it will get bigger. Keep it in mind, it will be bigger. If it's turned to be smaller, that means you do something wrong. Okay, so, it will be 2,480. See, you will move it 1, right, 2, and 3. Here, see, 3 places, 1, 2, and 3. Alright, let's try one more. What about this one? The digit less than 10. Check is yes. And what about this one? Negative exponent, right? So when you have negative exponent, you kick the decimal to the right or to the left. Very good. To the left. Alright, to the left. Now let's see. This is your answer. See, you kick it to the left. So from here, the old decimal, 1, 2, 3, 4. Okay? Don't forget. Or you can just count after the point, 1, 2, 3, 4, until this number, the old digit over here. Okay? See? You count to the left. And let's go for the Black Panther here. Or Batman. I'm not sure. Now let's see. This is negative exponent. Now, negative exponent will get big number or small number? Small number. Very good. So it will be count to the left. How many places? 7. Very good. Because you count number 5 over here, right? So this one place already. So how many 0 before number 5? 6. Very good. Oh, okay. It will be 6 0, right? 1, 2, 3, 4, 5, 6. And then 7 is here in the place of number 5 here. So this is how you do it, okay? Count to the left, 7 place. Next, 3.016 times 10 to the power of 9. Now this time it will be big or small number? Yes, big number because positive exponent. Now you kicked or you count or you changed the decimal point to the left or to the right? To the right. Very good. So you kick it how many places? 9 places. So 1, 2, 3. 3 already, right? It's here. So then how many 0 after number 6? 3 already. You need to move to 9, right? So it will be 6 0. 6 0. 6 0. See? 1, 2, 3, 4, 5, 6. Because you need to count 9 places to the right of this decimal point. That's it. That is pretty simple, right? Now you can do this. You can change the scientific notation to the standard form. You can read the scientific notation. Now, what do you have to do? What do you have to do? You will have to try to convert the normal number, the standard form, to scientific notation. It will be easy. Piece of cake, I promise. Now, don't forget the form will be 2 parts, the decimal part and the exponent part. Let's see, you have 137,000 here. What can you do? You need to find out what is A first, right? First part is a decimal. So, according to the rule, A cannot be more than 10. But it cannot be less than 1 also. But it can be equals to 1. So let's see what is A. Now, only 1 digit can be in front of the decimal point. So just put the first digit and then put the point after. And the rest, if it's 0, then you cut it off. So it will be 1.37. Very good. So just keep the first digit and then put the point behind it. And then after that, if it's 0, then you cut it. But until 7 first, okay? You need to read the decimal point too. Now, let's see. What about M here? M will be part 2. You move the point to match the new decimal and count. Now, just like that, it will be your point over here for the standard form. Then you count 1, 2, 3, 4, 5. Now, 5 places that you move, right? So that means how many? 5. Power will be 5. Just like that. Okay? When you put it back up, again, you can move 1, 2, 3, 4, 5. Same values, right? Same value. So that's it. Now let's see. The positive power is for the bigger number. See, this number is more than 1, right? But if it's less than 1, like this, decimal, guess what? This will be negative for the power. Alright, but first thing first, find A. What is the decimal for this? Find the first number that you can find. First digit will be 3. Very good. So it will be 3.2? No, you need to keep 0. If it's in between the number, you keep 0. Okay? So A will be 3.02. And then what about M? What about M? Move the point to match the new decimal and count. Remember, the old one is here, the new one is here, right? After number 3. So you count 1 and 2. 2 places that change, but this is bigger, right? 3.02 is bigger than the number that we convert. So that means it's negative power. Okay, so negative power for the smaller number. This one is smaller to big, so negative. This is big to small, so it's positive. Now let's try. Your turn. What is the scientific notation of this number? Let's start from Spider-Man. See, this one is small, right? Less than 1 is small number. So what do you have to do? You need to find A. What can be your A? What is the first digit? 4. Very good. So 4.5 times how many places that you changed? 1, 2, and 3, right? So times 10 to the power of negative 3. Remember, small number, it will be negative exponent from small to big because you change the digit, change the decimal here. Next, let's see next one. Wow, this is pretty big number. So what is the digit? What is the decimal? 2 will be your first digit. It will be 2.3. 2.3 times 10 to the power of, let's see, let's count from here, right? 1, 2, 3, 4, 5, 6, 7, and 8. 8. So times 10 to the power of 8. See, from big number to small, right? So that means it will be positive, because when you time this, it will get back to the value, the big value of it. So see, count, you just count the places. When you change the decimal point, change to here, and then from here you change to here, so just count the places. Okay, let's see last two example. Now 103,000. What can you do? Let me ask you this. It will be positive exponent or negative exponent? Positive. Very good. Big number, remember? And this, what is A? What is the decimal? 1.3? No. 1.03. Very good. Times 10 to the power of? Very nice. 10 to the power of 5. See? 5 places that changed, right? So 10 to the power of 5. Next, what about this one? What about this? 72.062. Now you change the decimal, right? It cannot be more than 10. So 72, no. It will turn out to be 7.2? 7.2062. You count all of it. But then you change from big to small. From big to small. You change the decimal. So it will be to the power of 1. Yes, you changed only one position, one place. See? So it will be 10 to the power of 1. So when you check your answer, you can just time it back, and then it will turn out to be 72.062, right? So you can also check your answer. Okay, it will always be the same values for the scientific notation and the standard number. Okay, now let's see. Review before we do some exercise, alright? Let's start from this. 9 times 10 to the power of 3. Start counting after the first digit. So, how many 0 after 9? Of course, 3. 3 places. And what about this one? 1 times 10 to the power of 5. Very good. Just count the places when you change the decimal, right? It's just like 1.0 over here. Alright, now let's see. What about this? 9 times 10 to the power of negative 4. Now negative, of course, it will get your small number, right? Less than 1. So, what happened? 0 before 9. Change from here, right? So, 1, 2, 3, 4. So, how many zeros before 9? 3. Very good. 3. So, start counting from the old point. See? It will be 3, 0 before 9 because it changed the position from here. 4 places. Next, what about this? 7. Very good. 7 times 10 to the power of negative. Don't forget. small number, negative power. Okay, how many places? 1, 2, 3, 4, and 5. Very good. 10 to the power of negative 5. Alright, now let's see. What about 0 then? Neither positive nor negative. Okay, if you have this 2.51 times 10 to the power of 0, what happened? Can you change to the standard form or the normal number? Just 2.51. Nothing changes because 10 to the power of 0 equal 1, right? Equal 1. So nothing changed. Okay, now more examples. Let's see. Convert each number into scientific notation. Number 1, 4,000 equal 4 times 10 to the power of 3. Very good. How about this one? 306 and 6 million. What about this? 3.06. Very good. Times 10 to the power of, just count the places. 8. Very good. Next, number 3. 0.0004. Now, what is the decimal? 4. Very good. And what is the power on the base 10? How many places that it changed? 4. Very good. Negative 4. Don't forget the small number will get negative power. Number 4. 0.00000306. What is the digit? First digit will be 3, right? So it is 3.06 times 10 to the power of negative or positive. Very good. Negative. Negative what? You change the position 6 places, right? So negative 6. Nice. Alright, last one. From this, 892.021. So what is the digit? The first digit is 8, right? So you keep the rest of the number, okay? Now it will be 8.92021. Don't change the value, so you need to keep all the number. Times 10 to the power of, you change, right, from big to small. So same, big to small. It will be positive. Very good. So 10 to the power of 2. You change the decimal point 2 places. 1, 2. See? Let's move on to more examples. Now convert each number into standard form. So now I will give you an example of scientific notation. Now, number 1, 1.248 times 10 to the power of negative 6. So you just change, right? You just change decimal point to the left or to the right? To the left. Very good. To the left. So it will be 0.000001248. See? You just change here. So 5 zeros before number 1 here. It will change 6 places. What about this? 2.48 times 10 to the power of 3. Bigger or smaller? Bigger. Very good. So you put zeros after number 8. How many zeros? 1. Okay, you change the decimal point. 1, 2, and 3 will be 0 here. Alright, number 3. 6.123 times 10 to the power of 6. It will get big or small number? Big. Very good. So you put how many zeros after 3? 3. Very good. You change the decimal point. See? Next, number 4. What about this? 6.123 times 10 to the power of negative 5. Now, negative powers. What happened? It will get big or small? Small number. Very good. So you kick the decimal point to the left. This one will be 0 before number 6, right? How many 0? 4. Very good. Like so. Number 5, 4.002 times 10 to the power of 8. Now, positive will get big number. Okay, so just like that, you change the 0 You change the 0. And how many 0 after 2 now? You count 1, 2, 3. And the rest will be 5. Very good. So 5 zeros after number 2. Okay, that's it. Now it's your turn to do your worksheet part 1. What do you need to do? You need to write each number in scientific notation. Now let's see example. First part, you need to find the decimal first, 1.1, and then you find the exponent or the power on base 10, right? So you just count 1, 2, 3, 4, 5, 6 over here, right? So 10 to the power of 6. Next, part 2, you need to write each number in standard form. Now standard form, what you need to do? You will change, you put 0, right? You put 0, you change the position of the decimal point. Again, positive power will be bigger number for your answer over here. Don't change the value, just add 0. But how many 0 after number 2? You count, right? 1, 2, 3 already. And then this is 5, so 2 more. So it will be 2 zeros after number 2, the last digit here. Okay, now let's see part 3. Part 3, you need to write the missing forms about scientific notation in the real world. Now, I put together some examples of the real life number. First one, diameter of the moon. Pretty big, right? So the scientific notation is here. 3.474 times 10 to the power of 6 meters. Now, what can you do? You put 0 after the last digit, right? You change the decimal 1, 2, 3, 3 places already. So what you need to do? Put 3 more. Very good. Just like that, this is your standard form. And let's see one more example. How about number 2? Temperature at the core of the sun. Temperature, oh, it's very hot. It could be pretty hot. This is standard form, right? 15,600,000 Kelvin. Okay, so what is that? What is your decimal? Cannot be more than 10 or less than 1. 1.56, very good, times 10 to the power of, now this one is big, right? So the power will be positive. So count 1, 2, 3, 4, 5, 6, and 7. Very good. 10 to the power of 7. Yes, just like that. You need to find the rest of the answer yourself. Okay, continue until number 10 here. Alright, good luck everyone, and that's it. So see you again next time. Bye bye.